Have you been to a beach? Have you been to a beach in the afternoon? Have you walked on the sand? Burning hot, isn't it? Meanwhile, the water isn't that hot. But if you look at it, the source which is heating the bowl is the same, that is the sun. So why is it that one object gets heated up to such a large extent while the other isn't? To find answers, we need to look into the concept of specific heat capacity. Specific heat capacity is formally defined as the amount of energy required to change the temperature of a 1 kg object by 1 Kelvin. Basically, it tells us that different objects have different capacity to hold heat. The objects having greater capacity to hold heat would require a large amount of energy to raise temperature of an object by 1 Kelvin. Objects having lesser capacity to hold heat will require lesser amount of energy to raise their temperature by 1 Kelvin. The equation used to find specific heat capacity is given as Q equals to mc delta T, where Q is the amount of energy supplied, m is the mass of the object, C is the specific heat capacity, and delta T is the change in temperature. Let us look at an experiment to determine specific heat capacity. How do we set up an experiment to find specific heat capacity? First and foremost, we look at the equation. We rearrange the equation to make specific heat capacity as the subject. What do we require to find specific heat capacity? We need to know the amount of heat provided. We need to know the mass of the object. We need to know the change in temperature by providing the amount of heat. How do you find the amount of heat? For that, you use an electrical heater to heat the object. The power rating of an electrical heater should be known. You measure the time taken to heat the object. Power equals to energy over time. Hence, energy will be equal to power into time. The other two quantities, that is mass and temperature, can be easily measured using weighing scale and a thermometer respectively. The experimental setup to find specific heat capacity is as shown. An electrical heater immerses completely into whatever object you're trying to find a specific heat capacity of, along with a thermometer. Measure the temperature of the object, then start heating it for a given amount of time. Once that amount of time has elapsed, check the final temperature. Use the time to find the energy by using the equation Q equals to mc delta T. You can find the specific heat capacity of the object. Heat capacity of an object is defined as the amount of energy required to change the temperature of an object by 1 Kelvin. Unlike specific heat capacity, which only tells you the amount of energy required to change temperature of 1 kg of an object by 1 Kelvin, heat capacity tells you the object's entire capacity to hold heat. The formula to find heat capacity is given as Q equals to mc, where Q is the heat capacity M is the mass of the object, C is the specific heat capacity.